Right, so that's what we're going to do, is cut our board to size. Right, let's get that done. There we go. Here's our board all cut up. Just 6 pieces make the board up. So put it all together now. Right, the next stage is just gluing the board together. Just going to use some super glue. This is your positive rail here. So we'll start with that. Let's move over a bit, I think. Like that. Apologise if my hand's getting about. There we go. Next I'm just going to tin the board, just to make soldering a bit easier later. There we go, positive rail done. Just have a bit on there. There we go, all done. That's the board all done. Well, here's all the parts, and 16 parts. Get building. Alright, our first part is this 47k resistor. Alright, next part to install is the second resistor, which is the 22k. As you can see, I've cut these down to size. Try and get them as neat as you can. There you go. Alright, next resistor is the 100 ohm. Now this 100 ohm will give this transmitter about 8 or 9 milliwatts of RF power. Now if you want lower power, say 4 or 5 milliwatts, you can replace this with maybe a 300 ohm resistor. So basically, the higher the value of this, the more power your transmitter is going to have. There you go. Alright, we're on the caps now. Now this one is the output from the mic to the input, the base of the transistor. Now this is 100N, but this can be anything from 22N up to about 100 UF. So you've got a good selection of caps you can use there. Basically, the higher the value, the more bass in your sound. The lower the value, the more, the more tinny your sound's going to be. Alright, that's the first cap in. Alright, the next cap is the one in. Right, next cap is the 33 PF. And if you're going to build this transmitter like a lot of my subscribers do, this needs to be a 33P. These basically controls the timing of the oscillator. I apologise if the video gets a bit dark. I've only got my built-in light on the camcorder giving you, so oh, that one's done. Alright, this next cap is the 10PF going across the collector and emitter of the transistor. So this one's got to be a 10PF as well if you're building. Sorry if my hand's getting in the way. Right, next cap is the 10PF again. Now this is the output to the antenna. This can be anything from say 4.7PF up to even 100. And this is just the output. Basically stops a direct DC going down the antenna. There we go. The other end is for the antenna to connect to, so we'll leave that at the moment. Alright, last cap is the 100N across the battery. Basically this just keeps the circuit nice and tight. Oops. Not an ideal wire soldering, but I'm leaning over my camera. There we go. Let's pop that up like that. Job done. It's all the caps in, all resistors done. Alright, next we're going to install the 6-turn coil. Very easy to make, you can just wrap this around a drill bit. I used a 3mm drill bit. Just make sure, this is the coil, if you are making these out of one that's got enamel on, make sure you scrape it off. Most common mistake when building these, when using this type of wire, is not scraping enough enamel off. Right, that's still focused, I can't quite see that at the moment. There you go. See that? Coil in. Okay, the all important transistor next. This is a 2N3904. Great little transistors these are for these low powered FM bugs. They're very stable and they don't tend to move frequency very much when there's a drop in battery power lot. I mean, you can use other transistors like the BC447s, 448s, 449s, 450Cs, the 2N, 2222s. There's a load of them you can use. Try them, try all different ones. And different transistors will give you a different output on frequency. Obviously different, different in the way they use the current. Try what you got. If you're going to build this, that's the base done. Zip this up. I mean, you can put this in first. Just left it last, really, not one of the last components. Alright, that's that in. Cool. Okay, we've got our mic next. Make sure you get this wire around. Bit heavy with the solder there, but it's in on it. Right. Cool. Alright, next is our battery connector. If you're going to build one of these, try and keep the leads, battery leads, as short as possible. The longer these leads are, the less stable your transmitter will be. I mean, this is a very simple design, so it's not going to be the most stable transmitter in the world. But left in place, this will hold its frequency rock solid until the battery goes flat. I mean, what I'm doing, when I put the antenna on next, I'm going to be attaching it to this 10p cap, and that's coming from the collector side of the transistor. Now that is highly sensitive, so basically if you get near the antenna or touch the antenna, the frequency will drift just slightly. The way you can get around making it much more stable using a single transistor design is tapping the antenna off the second turn of this coil here. That will make the transmitter very stable, so you'll be able to pick this up like a microphone and use it without it moving frequency at all. But we'll probably get about a 50% drop in RF power So I'm building this one just to show you how much power we can get out of a tiny little transmitter. I mean, it's only a single transistor, so basically there's no microphone amplifier. So when I build these with the 2 transistor, the first transistor is the amplifier for the microphone, and the second one is the oscillator, basically creating, you know, the carrier frequency. And I do a three transistor design, so then you'll have amplifier for your mic, the oscillator, and an amplifier, RF amp output or buffer, which makes them highly stable. But this is the most simple design you can get. So basically I'm just showing you how easy it is to make a so simple transmitter, really. You know, you can get a surprising range out of this. In my car, I can detect these for about 800 metres, believe it or not. Alright, should we get the antenna in next? Alright, let's get the antenna in now. It's a bit tricky just leaning over out. There we go. So what I'm going to do now, just use this plastic tie. I'll tie up all the cables. Well, transmitter's all complete. Looks okay, doesn't it? I mean, you know, you can make this very easy yourself, no special parts needed. Should we zoom in now? Let's see if we can stay focused. There we are, there's all the parts installed. Next stage is testing. We'll test its RF output and see how it performs. Well, see you in a bit. Well, it's time to test it. We're going to test it with this frequency counter. Great little tool. Got this off eBay a few years ago. Great for testing these low powered bugs. Okay, let's plug in, shall we? There we go. Just put this on the battery, shall we? Let's just get that in view, shall we? Cool. 99.2 megahertz. So the way we adjust this, the frequency, so if we want to go higher, we'll just pull the coil apart gently. Oh, just moved up now to 104.4. We should get this to about, pull these quite far apart, we should get it to about 106.7. 106.1 megahertz. Oh, 102. Let's get it to about 103. So what we'll do, we'll go upstairs and test this next. I want it on 103.4. Oh, about there. Oh, there we go. So now it's all working. What we do next is just plug it into my wattmeter. There we go. Just adjust this camcorder. You see that? There we go. What we'll do now, just I would imagine this has got about, I don't know, between 6 and 10 milliwatts of RF power. Not a lot, but that, you know, this is only a single transistor FM bug. There we go. Oh, that's not bad at all. Can you see that? Right, 7 milliwatts of RF power. Well, the current draw is about, I think it's about 16, 17 milliamp. Alright, we'll take it upstairs next and test it. There it is. Pop upstairs, see if we can turn it in. So oh, look at that. There we go. Know the birds. I'll go ahead and build this yourself. No special parts needed. Very simple to build. Just follow the video and you'll get it right. Yeah, full RF power. Please subscribe to my YouTube channel if you've not done already. Any questions, just ask. Not a bad sound out of an bug. That hasn't even got a microphone amplifier. No, single transistor. Look at that. Full signal, 103.6 megahertz. Well, see you all soon.